Right. Yes, where we stopped last time means so just to revise what we did yesterday is we discussed about different positions on the celestial sphere and how to locate objects on the celestial sphere, and also uh, how the sky looks like for different locations on the earth, right? For example, we discuss how the stars are moving at different locations, for example, on the celestial equator, and also in north and south poles, and also in mid latitudes, what happens, right? So that's what we have discussed. So we discussed about rising and setting of the stars, and about the circumpolar zone, where we have this region where all the stars are just circling around without rising or setting. And then, so I guess we kind of stop somewhere here. Yes. Right. Now, so let me start from here. Now, something that we already know about our Earth is we are around 23.5 degrees tilted. So that means, so our axis is not like straight like that, right? The axis is like tilted 23.5 degrees, right? So that tilt, you can see that tilt clearly right here. And there are two circles that I have marked. The white circle is what we called as a celestial equator. And then apart from that white circle, there is another circle from the red color, right? So that is called ecliptic, right? So ecliptic is basically defined as the path of the sun, right? How the sun moves on the sky. And if you look at the general movements of other stars, other planets, and also the moon, they are kind of following this ecliptic path, right? So that is something that you need to understand and learn. And I will also show this information from the stellarium software in a minute. And the other thing is about this, when the Earth revolves around the sun, since we sit on a platform on the Earth, we see that the sun moving around the sky, right? So that's what we usually see. The sun is moving around the sky. So this name ecliptic came as the circle in the sky that the sun appears to make around us in the course of a year is called the ecliptic. Now, if you look at very carefully the positions that the sun rises and sets in each month or during an year, you will see the sun doesn't rise always from the same location. We used to tell that the sun rises from the east and then the set from the west, but that doesn't happen always, right? It's kind of the rising and setting point of the sun is kind of moving throughout the year in a certain pattern, right? So that you will easily identify it. And so I will show this information probably towards the end of today's lecture on the next day by using this software. And there is another thing that is attached to the same concept. This path of the sun or the circle will go through different set of constellations, right? And what Asian thought about this constellation is that the sun is kind of, and also moon and the other planets are visiting these constellations, right? And they thought that there would be something special incorporated with these movements on the sky for their systems of astrology, right? So they incorporated this concept into astrology. I guess you know what astrology is. Please understand that the subject astronomy and astrology are two completely different things, right? So astronomy is like the science of the sky. Astrology is completely different thing. And you can see that this is how our new year is also defined, right? So this the sun is kind of visiting each of these constellations, and depending on which constellation a particular sun, which constellation in the sun is in, we kind of decide different things in astrology, which we will not talk here. Right. So let me have this question for you. If there were no clouds in the sky and we were on a flat plane with nothing to obstruct our view, how many stars we could see from our unaided eye? So that means, let's say in a certainly fairly dark location on the earth, if you go there and if your surface is, or if your outside is completely flat, that you can see all the horizons around you, how many stars, generally how many stars will you see on the sky from your unaided eye, which means just without using a telescope or anything, how many stars will you see? Do you have an answer for this one? How many stars will you see in the sky usually? What do you think about it? Now the problem for me is that none of you are actually talking, and I don't know, this is a completely online class, right? So you need to talk at least a little bit, otherwise it's hard to continue this discussion. So do you have an idea like how many stars that you will generally see up in the sky? A number, just a rough number, maybe 1,000, 2,000, 3,000, like that. Anybody have any idea? Yeah, I got an answer called around 2,000 to 2,500. So that is pretty close. Now, these slides are actually uploaded for you in the Google Classroom probably 1 or 2 weeks ago. So if you go to the notes before you come to the class, you will probably have that answer. The rough number we used to tell you is around 3,000. Right. So if there were no clouds in the sky and we were on a flat plane with nothing to obstruct our view, we could see about 3,000 stars. So your answer is pretty close to that with the unaided eye. So that is a general number that we have. Now, the ancients found groupings of stars that made some familiar geometric patterns. Right? Now, from the ancient time, these people have this ability to group the stars that they think that they are, located in a certain pattern, right? Sometimes it's an image of a bear or something like that. So like that, they have these star patterns on the sky, right? And the primary use they had with these star patterns is that they were very helpful in navigating among the stars. So once you identify these patterns on the sky, it makes a lot easier for you to locate the objects, right? So that is one of the main advantages now we have as astronomers. Now, for example, there is a star pattern called Orion, and the specific name for star patterns are called constellations. So we used to tell that the Orion is a constellation, that is a pattern of stars. Now, the advantage is once you locate this star pattern on the sky, you can actually locate Orion Nebula. So there is something called Orion Nebula. It's a nebula. Actually, you will learn what is a nebula. It's a place that where you have a lot of new stars forming, and it's a beautiful view of the sky if you get a chance to look at that. And so, for example, let's say you go for an observing session outside using a telescope. And if you need to locate the Orion Nebula, what you will use to do as the first step is try to locate the Orion constellation. So once you locate the constellation, in the constellation, there is a specific region that we know that the Orion Nebula should be located. So then you can point your telescope very easily for that particular location, right? So that's kind of a practical usage uh, of these constellations or this grouping of stars. So that's what I mean from this third sentences, which the third sentence that I called as this is very helpful in navigating among the stars, right? So you can go from one place to the other place on the sky using these star patterns, right? Now, some of the well-known older star patterns are Big Dipper, Little Dipper, and Orion. So these are very famous. The other important thing that you need to remember, as I have highlighted from the last sentence here, is that many of the stars that we see are not part of these distinctive star patterns at all, and a telescope reveals millions of stars too faint for the eye to see. So this is the reality. Even though we have a lot of star patterns that we have defined on the sky, still most of the stars on the sky don't belong to any of these star patterns, right? Even if you, for example, if you use a telescope, you will see huge number of faint stars that you cannot even see from the unaided eye, right? But the specific thing about the star patterns or the constellations is that these particular set of stars are bright so that you can easily locate them from your unaided eye without using a telescope. And then they make a kind of specific patterns on the sky so that you can identify them easily and use them to navigate through the star for different objects, right? So that is the advantage. Right. Now, if you are familiar with the sky, so maybe there are some certain students who used to have a habit of looking at the sky. And anybody let me know what is this constellation that you see here? What is this particular constellation? Anybody have an idea? What is this constellation? So there is a constellation in this picture. That's a pattern of a star. And anybody knows? Can anybody identify with these bright blue stars? What is this constellation? This is a very popular one, in fact. Right? Please talk, right? So don't be afraid to talk. So nobody knows what is that. Yes, exactly. So there is one answer. Thank you for that. This is constellation Orion. That is exactly the same constellation that I have just mentioned a minute ago. And if you yes, anybody have any questions to ask? I was wondering whether somebody raised to answer a question. Raise your hand to answer a question. Right. So anyway, so let me have this to let you know. These three stars right here is what we call as the belt of the Orion. This is called Orion belt. and there are three. Right, so I think it may be easier to identify these specific locations from this particular graph. And this is an image of the Orion constellation, and you can see there are three stars on the belt of the Orion, and those are the three stars that represent the belt. And then you have these different stars, and there is one very bright star right here. It's a very famous star. Anybody knows the name of this particular star? And you can see from the text, if you read through this text in mentioned as part A and B, the name of this particular star is actually called Betelgeuse, right? And then again, there is a bright blue star right here. It's a very bright one, and that is called, what is that star? That is called Regal, right? Now, these stars are the reason that I am just mentioning these names is actually, it will be very helpful for you practically when you look at the sky. Once you can identify these bright stars on the sky, it is very easy to locate these places on the sky and navigate through the sky, right? Because by the end of this course, you should learn these basic theories and stuff behind astronomy, and at the same time, you should have this practical knowledge to look at the sky and then locate different objects and identify these basic objects and constellations on the sky, right? So otherwise, there is no point of doing this astronomy course if you cannot identify anything on the sky, right? So remember that everything that you learn here, try to connect it through an observation. Just go outside and look at the sky, right? So that's why I asked you to look at the sky yesterday as well. Now, right now for currently for the constellations, astronomers from many countries, there is a union called International Astronomical Union. So they have actually established a more formal system to organize these constellations on the sky. And they have a standard 88 constellations defined now on the sky, right? So there are 88 constellations, and these constellations actually belongs to both northern and southern hemisphere. And some people have this word called asterism to denote an especially noticeable star pattern within the constellation. So asterism is a subgroup of constellation, which is a sub pattern that you can easily locate, right, or noticeable in the sky. Now, for example, this name Big Dipper is an asterism. Actually, in the constellation Ursa Major. Ursa Major is the big constellation, and then the Big Dipper is a kind of a small part of that you can easily locate or notice on the sky, right? And if you, before I move on to the next section about the ancient astronomy, I would like to just show you one. Let me just stop sharing this and then just share you one link. I think I posted the same thing in your into your Google Classroom, which is a Facebook link. Let me share this with you. This is just to show you these the things that how these things are applied, right? I think all of you can see this particular image, right? So this is one of the beautiful images taken at the Kitt Peak National Observatory, and this is located in Tucson, Arizona. And something that you should not, there are different things that you should learn from this picture. One thing is that these very large telescopes are usually located at mountains, right? If you look at all these large telescopes in the in the world. So they are usually located at mountains. And you should understand there should be a reason for that. So try to search in the internet and find the reason why all these telescopes are located in mountains, right? And so this is actually picture taken, I guess, in last week from the Kidd Peak National Observatory. And this particular observatory is located in a place called Tucson, which is a city in the Arizona state in USA. And I used to know this place very well because I have been using this particular telescope that you see in the image for my observations few times. And I have been to this mountain few times. So it's the in reality, when you need to do real science observations, you have to be in a very dark place. So that is one reason why you use mountains. And there are a lot of other reasons for that as well. And this is a very nice place without any kind of light pollution that you can observe the sky very nicely. And this particular image that you see here is what is important is not this telescope. By the way, the size of this telescope is a 4-meter class telescope. That is what I mean from 4-meter class is the diameter of the mirror that they have used to construct this telescope is 4 meters. So it will be a very, very huge, like our room, kind of a size of our room, right? The mirror only. And that's why it has this large structure to locate this particular telescope. And there are, five storage built in this one. And there is a lift inside. And then you can travel through the lift. And there is a kind of an office space inside the telescope where you go there and use all these telescopes and controlling mechanisms to rotate the telescope and start observing. And this particular part right in the upper end is called the dome. And if you carefully look at, there is a place right here that looks like a small door, right? So this door will be slide up and down, and this is already slide towards the down region and has opened the window right here so that the telescope will point to the sky through that particular point, right? So that's something extra that I just explained to you. So what I need to mention here is there is a nice constellation here. Can you see what it is? Can you name it? Can you identify that there is a constellation? One thing that you should understand is constellations always come from the brightest stars, right? So can you identify what is the constellation here in this picture? Anybody have any idea about this picture or the constellation? So I'm just allowing you to give just some time to think about these things, right? What is that constellation? This is one of the famous constellations in the northern part of the sky. So I just expect from you by the end of this course, you should be able to identify these basic constellations at least, right? This is in fact actually not the constellation that I need to highlight. This is actually the asterism that we just talked a few minutes ago. This is the Big Dipper asterism. So I assume that you can see my cursor, right? So these 4 stars right here and these 3 stars kind of make that Big Dipper asterism, which is a subpart of constellation Ursa Major, right? And there are certain stars right here that are very popular, right? So these two stars right here are kind of very popular. And also this Big Dipper asterism is why mostly used to locate the North Star or the Polaris. I guess all of you have heard about the star Polaris, right? Now, how do we locate the star Polaris from this picture? So the way that you do is once you locate these two stars, so first you locate the Big Dipper asterism and then you locate these two stars right here. And if you draw a straight line towards the downward direction up to here, this is where you have the North Star. You can see the North Star is right here. And this North Star is very important in astronomy because it's kind of the star that we believe that the location is, the location doesn't change, right? Usually. But there is a way that it actually the location changes. But for the time being, it's kind of a reference star on the sky. So it is always easier for us to locate everything else when you locate the North Star. Now, this North Star is very close to the North Pole, right? Now, what do you think for us? Where will be our North Star? Will it be directly up in the sky, like close to our zenith, or will this North Star will be close to our horizon? What do you think? From the knowledge or the things that we have learned yesterday, where will be our North Star? Will it be close to the horizon? Will it be close to our zenith? What do you think about the North Star? Location of the North Star. Now, these are the things that you should be able to, decide based on the knowledge that you have gained from the previous lectures. Right? So, what do you think about the location of the North Star? Yes. So, it is close to the horizon. Right? So, I can see just only always one or two of you are always answering and all the others are silent, right? So it should not be like that, right? So make sure that you all are involved in the class and answer this question, right? So that is exactly correct. For us, the North Star will be very close to the horizon, and it is even harder to locate the North Star for us because it's very close to the horizon. The reason is that, as you have learned yesterday, the North Pole, celestial North Pole, is our horizon, right? So this particular North Star is very close to the horizon, and because of that, we will barely see this North Star from Sri Lanka, right? But it is not the case for the other countries. For example, this Kitpik National Observatory is kind of around 40-degree latitude, 40 to 45 degrees. So the North Star is kind of halfway or in the middle between the North Pole and the horizon region. You can see the North Star. And we used to locate, so the first thing that when you go outside and try to do observing, for example, when we went to Arizona, we used to try to locate the North Star first. So if you want to locate the North Star, we usually try to get or try to identify the Big Dipper first. Once you identify the Big Dipper, we straight away know that this whitish type star right here in that side, if you draw a line towards that side, next bright star that you meet up in the sky is the North Star, right? So that's how you identify, right? So that's, I just need to give you some information about this, the information actually about this constellations and how we actually use those, right? So let's come back to the next section of the lecture. So let me share the screen again. Right, so I would assume that you all can see the screen again, and let me switch this to the full screen on the slideshow. Now, up to now, as the first section of this course, what we have learned is how our sky looks like, very in terms of very basic information at different points on the earth, how the stars are moving, what kind of things that we can observe from different locations, and where is our horizon, where is our zenith position, and how the stars are moving at different locations, and then what are constellations, why those constellations are important for us, and how we can identify some of these constellations very clearly up in the sky. So those kind of things, we kind of got a very general information about the sky, right? So that's what I want from you to know from this particular section. And next, before we go into in detailed things about the motion of the stars, planets, those kind of things, let's look at a little bit of history of astronomy. So this section will be about the ancient astronomy. And so on the next day, we will move on to talk about the orbits of the planets and those kind of things. But for the today's lecture, let me go through this section about the ancient astronomy, right? Now, when you go back to the ancient astronomy, the story is very long. There are a lot of information. So I just few points just to connect you with the modern astronomy and the ancient astronomy. Now, the one thing that I would like to talk is the shape of the earth, how people knew that the earth is, spherical or the round shape, right? Now, still, there is a society called Flat Earth Society, right? So there are people who used to think that the earth is flat for some reason. And they kind of try to collect evidences for that as well. But the reality is that the Aristotle, who was one of the philosophers at ancient times, had convincing arguments that the earth must be round. Right now, his argument was very nicely built around one of the natural incidents that we used to have, that is lunar eclipses, right? So I hope all of you have heard about these eclipses, lunar eclipses and solar eclipses. So what Aristotle thought is Earth is round based on the observations that he had about the lunar eclipses. His argument is actually when moon enters or emerge from the Earth's shadow. So that's what happens during a lunar eclipse. We will talk about eclipses later. But when the Earth enters and also emerge and exit, when the moon enters and emerges from the Earth's shadow during an eclipse, we can very clearly see the shape of the shadow, right, seen on the moon. And that shape is always round. And if you look at this particular series of images, you can see that the moon enters to the Earth's shadow from the left side. It starts entering to the Earth's shadow, and you can see gradually at this particular point where you have this red moon, it has completely entered into the shadow of the Earth, and then it exits after that. So at these entering points and exiting points, you can see the shape of the shadow, right? So that shadow shows you clearly a spherical or a circular shape. And this is the evidence that Aristotle used to tell that our Earth has a round shape. Now you can, the take-home message from this particular observation that he had was, you can see that how these ancient astronomers and scientists make decisions, right? So they make observations, and then they critically analyze the observation, how the observation looks like, what are the features, and then they make decisions, right? Now these decisions are logical because of that reason. Even though this is a very simple incident, you can see that how he his decision, right? Right. Now the next thing is, so these Greek astronomers, they actually not only knew that the Earth was round, they tried to measure the size of the Earth as well. Now, to measure the size, they kind of use an interesting concept, that is, for a source infinitely distant, the rays travel along parallel lines. And you can see that from this picture, and they use this particular method to get an idea about the size of the Earth, right? And then if you go for this particular image right here, so since this is a kind of the ancient details, I will move a little bit quicker so that we will have enough time to discuss the other things. And this particular image right here shows you an effort that these Asian astronomers taken to measure the size of the Earth again, right? Now, it's kind of related what I have discussed earlier. The way that you can measure is you can measure the size of the Earth by observing the angle which sun rays hit our planet's surface, right? The way that you do it is, if you look at, this is an image right here. Now, you can see that since all these lights, rays coming from the sun are coming from far away distance. So they used to be parallel, right? All these light rays, they are coming from millions of kilometers away from us. When they come towards the Earth, we usually get parallel rays, like these yellow rays that you see up here. And it's kind of an enlarged version of the same image right here. However, when you look at these parallel rays from two different locations, you can see that we will observe an angle because of the curvature of the surface that we are living. We know that the Earth is round shaped, and because of the curvature, we will see it from different angles. So that's what I have mentioned here. The sun rays come in parallel, but because the Earth's surface is curves, a ray at Scene means a name of a village or a town, comes straight down, whereas the rays at Alexandria makes an angle of 7 degrees in the vertical. You can see the rays are straight right here, but when you measure the same parallel rays at right here, you can see that because the curvature that you have on the surface, now your rays are actually angled, right, compared to the surface. So that angle is around this much of degrees. So once you measure this angle of the rays, you can get an idea about the distance, right? So how they have measured here is, this angle is around 7 degrees for their experiment. And that means the Earth's surface has curved away from sine by 7 degrees, right, of 360. So that you can get an idea, right? So for this distance, the angle is this much, so that you can measure the complete size of the Earth. So that's how they have done it. Now, his measurement was actually not exactly correct at that time, but it was very close. And the idea that I want to convey here is the power of thinking that human had from this ancient time, right, to do these conclusions, observations, and experiments, right? Right. So by coming from these basic experiments, by looking at, the shape of the Earth and size of the Earth, and then when it comes to 150 BCE, this one of the famous astronomers we call Hipparchus, he actually started to measuring the positions of the stars as accurately as possible, and he has made the first ever star catalog with 850 entries. So he got this 850 entries to a star catalog, and he also divided these stars into apparent magnitudes according to their apparent brightness, right? So what he has done was he tried to locate all these bright stars and make the positions of these 850 stars and made a catalog. So we call these kind of entries as a catalog of stars. And he has 850 stars with their positions recorded. And he also divided these stars into their apparent magnitudes according to their brightness. So this is where the magnitude scale came into play for stars and all the other objects in astronomy. So what he did was, based on his visual observation, he assigned a number to the brightness. Now, how he assigned the numbers is, for the brightest objects, he assigned a number. And then for the next brightest set of objects or set of stars, he assigned another number. So that's how he convert this brightness of a star into a magnitude, right? So this is the first ever attempt to give a number for the brightness, and this is called apparent magnitude. And at the same time, he made one of the remarkable discoveries, that is the position in the sky of the north celestial pole had altered over the previous century and half. So that is interesting, because our normal assumption is the axis of the earth is kind of pointing towards the North Star. Now, as I have mentioned previously, from that image taken from the Kippik National Observatory, we used to think that the North Star as our reference point, because it is very close to the North Pole and it doesn't change, right? But what Hipparchus has mentioned is that the position in the sky of the North Celestial Pole, that the position North Celestial Pole had altered over the previous century and half. So over the last 150 years, this position of the North Celestial Pole is gradually changing, right? Now, this is something that we never talked before. However, today we understand that this direction in which the Earth's axis point does indeed change. However, it is very slowly, right? And this particular change has a specific name, and we call that as a precession of the Earth, right? And this is what exactly that means, right? So you have, you have our North Pole right here. When you projected it to the sky, this is around the North Celestial Pole, and this is where that North Star. And the idea was, when our Earth is rotating around its own axis, this point is not changing, right? So the North Star is not changing. You can keep that as a reference star. However, what Hipparchus found is that the position of this axis is also changing over a large period of time. And this is exactly what happened. So this position is actually moving around the sky. However, this particular movement will take a very long time. And in fact, to complete this circle and come up to this point will take 26,000 years, right? And this is actually very similar to a spinning top. I don't know whether you have seen it before, but let me just show you this. It is something like this. So you have this, let's say you take this pen right here, and let's say you have this pen right here. Let's assume that this is our axis of the Earth, and we usually think that this axis does not change, and our Earth is moving just around this axis for every 24 hours, right? But what actually happens is, this particular axis is also moving very slowly like this, right? And this is called precession. And this, like that, it is moving. I don't know whether it's clear for you from my image. So this is called precession of the Earth's axis. However, this movement of the axis is very, very slow compared to our lifetime. It takes 26,000 years to complete this particular movement. And you can see that that means per 1 year, the movement is very, very small, right? And because of that, we still assume that our axis, Earth's axis, is not make considerable changes over a 10 to 15 year of time, right? However, when you consider a larger larger time gap, for example, like 50 years, there will be a small change in this precision, this point of the, the reference point. And because of that, when astronomers are actually make observations and locate points, they make they make these slight changes to the coordinate system for every like 40 to 50 years. And they have used to mention it in the catalogs. So if time permits in future, I will show with an example. These coordinate systems, they usually mention the year that they refer. So we usually used to have 1950 coordinate system, which is 50 years, 70 years ago. Now we used to have 2000K coordinate system, which is a newer one. And that small adjustment is done due to the precision of the Earth, right? So that is the practical usage of what you have to do practically because of these movements of the Earth axis, right? Hope that is clear for you now. And now, even though, as you can see in the text here, even though we used to tell that our North Star is now Polaris, which is near to the North Pole, however, around 5,000 years ago from now, it was close to this star called Tuban, right here, right? And 12,000 or 14,000 years from now, this our reference star will not be the Polaris, it will be Vega, right? So Vega will be our pointing star at that time, right? So like that, keep changing, right? Right. Now so let me, now that's some of the historical things that we need to understand. However, I just try to present it in a logical way so that you have an idea what we are talking about, right? And then when we talk about our solar system, which means including our sun and all these planets, the most important contribution came from Ptolemy at that time with the geometric representation of the solar system. So he located different objects geometrically. And the problem is actually at that time, he thought that we are at the center. So Ptolemy thought that we are at the center and all the other objects, including the sun, is moving around us, right? Now, the complicating factor in explaining this kind of motion is that there are planets wandering in the sky. So that means that if you think that we are at the center and assume that all the planets are moving around us, that's okay for a certain time. But once you go outside and observe, then astronomers have located that there is this retrograde motion for some of the planets. So that means this retrograde motion is, let me go into the next slide and show you what this retrograde motion means. Now, we now know that the sun is right here, but at that time when they kind of, have this idea about this first geometric representation of the solar system, they put Earth at the center, right? Without knowing it. So what has happened was, when they observe the sky, they sometimes see there is a planet comes moving this towards this way and then it goes backward like that and then move forward. And this is what we called as a retrograde motion. Now, assuming that our Earth is at the center and everything is moving around us, astronomers could not explain this. So the Ptolemy had the same problem, and what actually happened was they came up with this model to explain it. So we are at the center and they put that everything is moving around us like that. However, each planet they put another circle. This is called an epicycle. So once you are right here, and if you put this hypothetical epicycle that you believe that the planet is moving around this epicycle, then it makes sense, because then sometimes you can see the planet goes forward and then in this area when it goes backward, you can see it goes backward, right? So that's how they explain it that time. However, later we identified that it is not the case, and it is not the case. that actually the Earth is not at the center, the Sun is at the center. But once you keep the Sun at the center, then you can identify, you can see what happens, right? Sun is at the center and the Earth is moving like that. And then let's say this is Mars, which is the next planet, is moving in the next circle. And you can clearly see that these two planets have different speeds. And sometimes these planets may be going a little bit, forward compared to B. And when it comes to C, this is a little bit behind because the Earth is kind of moving a little bit faster because it's close, right, to the Sun. And then at the point D again, this particular planet mass goes backward, and after some certain point, because we are moving around the circle, when you go to point E, then the mass is moving forward in front of the Earth, right? So this is what actually happens. But at that time, what happened was, because we thought that Earth is at the center, they could not explain it. So then Ptolemy had to add these epicycles to explain it. But now we know that this concept is wrong, right? And we are not at the center, Sun is at the center, and all the planets are moving around us, right? Right. Now to finish this and more movement, so we will talk about the birth of modern astronomy on the next day. I will just finish this section just having a very brief, introduction about the horoscope. This is totally unrelated to us, but just for your general knowledge and to differentiate between astronomy and astrology, let me have these few words about the horoscope. My question is, do you believe in horoscope? So I need an answer from you, at least yes or no. What do you think? This is not a thought, like I just believe to get your view. So I'm not going to comment on that, because different people can have different beliefs. I'm just wondering whether you believe or not. Would you like to answer for that? Do you believe in horoscope? I hope all of you. Is there anybody who doesn't have horoscope? Usually most of us have horoscope, right? Is there anyone who doesn't have horoscope? Or do you believe in horoscope? Right, so I wouldn't expect you to answer for that unless you are volunteer to answer. However, this is the story behind the horoscope in kind of a partially scientific view. Ancient people thought that the planets and the stars are representatives or symbols of the gods or other supernatural forces that control their lives. Right, so that was how ancient people thought about the planets and the stars. So they kind of thought that these are kind of, representatives or symbols of the god or supernatural forces, and they can control their lives. Now, the subject astrology began in Babylonia about 2.5 millennia ago, and this key to this natal astrology is something called horoscope, which we are still using. And what this actually represents is a chart that shows the position of the planets in the sky at the moment of an individual's birth, right? So it's basically position of the planets when you when you are born, right? And then you are assigned a particular sign based on that, right? This is called your zodiac sign, and that sign is actually is the sign the sun was in at the moment you were born. So that sign is basically where the sun was when you were born, right? Now, if you remember this picture right here, that picture is this one. I guess this one right here. You can see that the sun is at different locations, and there is in the background there is a certain constellation, right? So those are those 12 constellations, or you call that as zodiac signs in astrology. And right, so let me come back. Yes, so that's how your horoscope and your zodiac sign is given. Just a comment that it's hard to imagine how the position of the sun, moon, or planets in the sky at the moment of your birth would have anything to do with our personality or the future. So that is the comment that I have on the science. Right. So these are those zodiac 12 zodiac signs usually given. Right. So on the next day, I will start with the birth of modern astronomy, and there is a small section that I will be discussing about the birth of modern astronomy, which is about the Copernicus telescopes and the observation. Just 1, 2, or 3 slides, and then I will be moving on to the next section that we talk about the orbits and gravity. So that means how actually you can talk in terms of physics about the movements of the objects, and the phases of the different, how the objects are moving, what kind of paths that they are moving. So there will be a little bit of physics involved, such as Kepler's laws, basically, in that section. Right. So anybody have any questions up to here? Any questions, please?